Hey again everybody, here is just a quick little video on some of the notation that you're going to see in section 2.2. We already kind of mentioned, if f of x is, the x squared function, if I want the derivative of f of x, you'll see it written like this a lot, sort of read as f prime of x. And we've done this one a billion times now, and you know that one's going to be 2x. All right, if I wanted f prime of a, then I would have 2a. But since we now know that we can use the derivative as its own function, I'm going to actually call it f prime of x instead. Okay, so the derivative of x squared is 2x. That's how you would read that. You can also see the notation that looks like this instead, which is also the derivative. In fact, this one comes directly from delta y, delta x. If you think about old-fashioned slope, because if you remember, the derivative is just simply slope. So just a notational thing to kind of so you recognize it when you see it. The other thing you're going to see in this section is something that looks like this, where it's the second derivative, or if I'm going to use the other notation, this is what it's going to look like there. And if you want the second derivative, you really just do the same thing. You take the derivative of the derivative. So if this is your first derivative, you would then find the derivative of that. So if I wanted to do that, this is how I would do it. I would use whichever method you want. X to a is fine. So this is going to be the limit as x goes to a of f of x minus f of a over x minus a. And if you want, I'll do the other method too. We can simplify that, of course. And all you're doing is the same process that you've done a million times already. And that value ends up being 2. So the first derivative of x squared is 2x, while the second derivative of x squared is 2. And just for the sake of showing it both ways, let's find the second derivative using the h to 0 method. So this is going to be the limit as h goes to 0 of f of a plus h minus f of a all over h. So I plugged in a plus h wherever I saw x. I subtracted out f of a, so I plug in a wherever I see x, and then I simplify. The limit as h goes to 0. This is going to be 2a plus 2h minus 2a all over h. And you can see what's going to happen here. The 2a's cancel. The h's cancel, and when the dust settles, you're left with just 2, which is not a surprise based on what we got before. So again, the way you would read that would be the first derivative of x squared is 2x. The second derivative of x squared is 2. All right, and I think that should pretty much do it for you. If you need any help with any of that, be sure and let me know, and I will talk to you guys later.